A very good habit to get into is regular backup of your work. In this course, occasionally I'll be encouraging you to take a backup of your Raspberry Pi's SD card as we complete some of the major milestones throughout the project. And getting into the habit of taking backups occasionally, at least after a milestone has been achieved, will save you a lot of time if something goes wrong after that milestone and you need to repeat some of the work. Instead of going back to the very beginning and starting essentially from scratch, what you can do then is to go back to the previous backup instance that you know that is working properly and just start again from that point. And that can save you, as I said, a lot of time. So how do we take a backup? Let me show you. The first thing you need to do always when you do a backup of a computer is to properly shut it down. Don't just pull the power cord. You need to shut down using the shutdown command so that the operating system has got enough time to gracefully turn off any running processes, close files, and just make sure that there is no damage in the file system that you'll be backing up. Let's do that now. First, I'm going to log on. I'm going to log on as Pi instead of root. And shutting down Raspbian or any Linux system is an activity that a normal user can't do. So you will need to either switch to root or use sudo to temporarily become root for a single instruction. So that's what I'm going to do here. I'm going to say sudo in order to execute the instruction that follows as a super user. Shut down. And there's a few options here for shutdown. You can either use, say, the R switch. R stands for restart, in order to get your Raspberry Pi to do a reboot or restart. Or in our case, we'd like to shut down and then hold. That's what the H stands for. It will shut down and it will stay shut instead of rebooting. And you also need to tell the shutdown command when you'd like the shutdown to take place. So of course, we want it to take place right now. So we'll just say now. So hit enter and the Raspberry Pi will start its shutdown process, and give it a few seconds. It's quite quick, about 10 seconds is enough to have your Raspberry Pi shut down. You can see here on the Raspberry Pi's LEDs that just the red LED, the power LED, is on, and there is no activity on the green LED. So that means that it's safe to remove power, and now we can remove the SD card. So I'm going to use my SD card adapter and insert it into my computer's SD card slot. On my computer, I've inserted the SD card into the SD card slot, and you can see on the Finder that this is the boot partition of the SD card. On the Mac, in order to take a backup of this SD card and create an SD card image, I'm going to work on the command line, and you use the same process on Linux as well. So on the command line, the first thing you need to do is to find out the location where the SD card has been mounted. So the command for that is disk util list, and you'll see a list of all the disks that are mounted on my desktop computer. The one that represents the SD card is this one here. You can see as a Linux partition, it's 15 megabytes after we expanded it earlier when we configured the Raspbian operating system after installation. And the thing that is important right here is this. This is the location where the SD card is mounted on my computer and where I can access it. With this information, I can go ahead and do the backup, create the image for the SD card. This is also a operation that requires super user access. So on the Mac, I'm going to use sudo. dd is the command that will do the backup. And I need to provide two parameters. One is the input file. The parameter is if. And here I need to copy the location, the mount location for the SD card, like that. Then I need to provide the output file. Where is it that I'd like the dd command to store the image file for the SD card? So I've got a backup, a special directory where I put my Raspberry Pi image backups. So it's just there, and I want to give it a name. Now, when you give a backup file a name, just think about the name so that it's easy a few days or a few weeks or even months later to use a file name as a clue about the contents of each backup. So in my case, I'm going to say that this is a Raspbian. Try this to get the spelling right. So this is Raspbian. This is Stretch. It's the light version. It's fresh installation, and I will also put the date. So it's let's say 6 February of 2018, and I'll use the DMG or IMG extension, or on the Mac I'll use DMG. Hit enter. Provide the root password for my desktop computer, and there's no output from the command. Once it starts working, it will just do its job silently without providing any output until it's finished. So this is a 16 gigabyte SD card. It's going to take a while for it to complete. Let's fast forward the process and have a look at what comes out the other side. And we're back 2,283 seconds later. That's about 38 minutes. So we've got a image created from the content. Say that we'd like to restore this image back to the SD card because we want to go back to this working version of our operating system and the build process of our application. What we do is exactly what we did in an earlier lecture where I showed you how to flash a fresh copy of the operating system onto the SD card. So again, we are going to use the same process here. The SD card, it's still in the SD card slot of my computer. So let's go ahead and restore the operating system from the backup file. Remember that this is the backup file that we want to restore. And the first thing to do is to double check the location of the SD card so that we don't overwrite anything else on our computer. So that's done with disk util and pass the list parameter. So down here, you'll see that we've got dev disk 3, which is our SD card, a 16 gigabyte SD card. It's a good practice to format your SD card before you restore it. So on the Mac, the way to do this is to use the new file system ms-dos command and indicate that this is going to be a 16-bit FAT operating system, FAT, and we want to pass in the target that we want to format. So that's going to be disk 3. Okay, that is quite quick. So the last thing to do is to do the actual restoration. So again, we're going to use dd as super user, and the input file system, or the input file, I should say, is the one that we created earlier. And then the output file is going to be dev disk 3. and the process will begin. It's going to take a while. A couple of hours later, the copying procedure from the backup image to the SD card is complete. It's about 10,000 seconds later. So this is the boot partition, and I'm going to eject in a minute from my computer and plug it into the Raspberry Pi and see if it reboots and if everything is as I left them just before the backup. Just one quick thing to look at, see the config.txt file here. If I have a look inside, you can see that these are the settings that I configured using Raspberry config a bit earlier. You can see the only change really that I made was down here where I set the GPU memory to 16 megabytes. So this is where Raspbian stores the settings that we specify in Raspberry config. Let's go ahead. I'm going to eject the SD card and plug it into my Raspberry Pi and make sure that everything is as I left it just before the backup. So I'm going to remove the SD card from the adapter, plug it into my Raspberry Pi. Alright, connect power. So the Raspberry Pi is booting. You can see the activity. The green LED indicates that. Give it a minute to finish up the boot process. Okay, should be enough time. And let's move it over to the computer and see if we can connect. I'm going to try to connect using root. Since access to the Raspberry Pi using the root user is not possible by default in a fresh installation of Raspbian. Right, so the password. And it works. So just the fact that I can boot into root is proof that the restoration of the backup image worked. The restoration process did take a couple of hours to complete, so it was very, very slow. That has to do with a couple of things, and that is probably the speed of the SD card. I'm not using a top performance SD card. I think I'm using a class 10 card only. So writing on that card does take a bit of time, but also it's the way that the restoration process works as well, which is quite slow, as it's going through moving data from the USB port onto the SD card. But even at that speed, the ability and the peace of mind to know that you can always move back to a good working instance of your operating system if something goes wrong is invaluable. So as I said again, I strongly recommend that you take a backup of your operating system as you go through this project every time that you achieve a significant milestone. Good copy of the operating system. To do the backup of your SD card, there's, again, just like with everything, there's a few different ways by which you can do it, but the way that I recommend is fairly simple, is to use this little utility called Win32 Disk Imager. So download it from here and install it on your computer. Before you execute it, what you need to do is to turn off your Raspberry Pi. Don't just unplug power and remove the SD card. You want to make sure that the operating system shuts down gracefully to make sure that any open files are closed and any services are turned off properly before you turn off power. So to turn off your Raspberry Pi, You need to connect to it via SSH. Let's do that now. Using PuTTY, of course, on Windows, and I can log on as, let's say, a root, since we now have a root user, and Raspberry as the password, default password, which I haven't changed. If I had logged on as Pi, then you would need to prepend sudo before the shutdown command, because shutdown is only available for super users. But because we are logged on as root, I don't have to type sudo in front of it. I can just say shutdown, and shutdown allows me to either restart or to shut down and hold the computer without restarting it. So that's what I'm doing now. I'm using the H switch, which stands for hold. If I wanted to reboot or restart the Raspberry Pi, then instead I'd use the R switch. Now I just want to shut down and not restart. So I'm using the H switch for that. And I also need to let it know when I'd like the shutdown to take place. So I could get it to shut down right now. So I type now, or say in 5 or 10 minutes from now, or a particular time. I can schedule a shutdown for some time in the future. So shutdown, H parameter, and now parameter, and hit enter. And the Raspberry Pi has started shutting down. It turned off the SSH daemon, so PuTTY is now disconnected and inactive. So I'm going to go over to my Raspberry Pi and unplug power and remove the SD card. You can see here on the Raspberry Pi's LEDs that just the red LED, the power LED, is on, and there is no activity on the green LED. So that means that it's safe to remove power, and now we can remove the SD card. So I'm going to use my SD card adapter and insert it into my computer's SD card slot. Great, I removed power from the Raspberry Pi, removed the SD card from the SD card holder, and inserted the SD card with its adapter to my Windows computer. And there is the boot partition on the SD card. So now that I've got that, and just notice that the boot partition appears as drive E in the Windows file system, I'm going to start the Windows 32 Disk Imager application. All right, so I've already got drive E here selected as a device. And let's choose a name for the image file. So let's make this name Raspberry Pi stretchy light basic config and the date when this is happening. So let's say the 7th of February 2018. I'll give it the IMG extension. So I'm creating here a file name for this image file that conveys enough information for me so that a few days or weeks later to know what the contents of this image file are, as I select one out of multiple ones to restore my operating system from. So it is worthwhile spending a bit of time to think about the name that you'd like to use, the name for this backup image file. You can also choose the location. So let's say I'm going to put this, and I'll just store the backup file in the downloads folder. Okay. Cancel that, and now I can click on the read button, which means that the utility will start reading data from device E and write it inside the image file. Don't worry about this, just a warning. So checking your free space will be skipped. Because I'm using a virtual machine here, this utility can't get a reading of the amount of free space that is available in the download folder. If you are working on a physical Windows machine, then you are not going to get this error message. Okay. It's going to take about 5 to 10 minutes to complete. And about 7 minutes later, the 16 gigabyte SD card in the meantime is that I copied the backup file inside the virtual machine instead of a network point as I had it earlier, just to make sure that Azure isn't having any trouble accessing it. So in your case, if you're using a physical Windows machine instead of a virtual machine like I am, you're not going to have this problem. So let's go to Azure and select the image that I want to restore. So I'm going to go to the PC on my local disk and pick the backup file. And Azure has already picked up my SD card, and I'm just going to click on Flash to start the restoration process. Yes. All right, so restoration process has begun. Flashing process has started. It's going to take about 11 minutes, maybe more. See how it goes. Just leave it alone until the process is complete. Great, so the flashing of the SD card with the backup file is complete, and now Azure will validate that the restoration is complete and good. And finally, about another 15 minutes later, the verification process completes. So now we've got an SD card with the restored version of the operating system on it. Azure has also ejected the SD card from the computer, so I'm going to go ahead and insert it into my Raspberry Pi and apply power, and then see if I can connect from Windows again to my Raspberry Pi with the restored version of the operating system and see if everything is just as we left them before the process began. So I'm going to remove the SD card from my computer and get it out of the adapter and plug it into my Raspberry Pi. So this is the SD card that contains the restored version of the operating system. And now I'll apply power and begin the boot process. Okay. So the Raspberry Pi is now booting into the restored version of the operating system, and I'm going to give it a few minutes, maybe actually half a minute to a minute is enough for this to complete. Just going to wait for the activity to slow down, or that would indicate that the boot process has completed. All right, that should be enough. The green activity LED is just slowed down. There's not much. Oh, there is some activity now. Anyway, there should be enough time for it to boot. I'm going to go back to Patty and see if I can connect to it via SSH. Let's try this out. I'm going to start PADI and try to connect 192, 168, and 35. And since this is the restored version of the operating system, I should be able to connect to it via root. So that's a test I'll do. If I can connect to it via root, then I know that I'm using the restored version of the operating system and not the previous one, the original one. Yes, so it looks like we are able to use the version of the operating system that we backed up earlier, the one that had a few basic simple modifications, like we enabled ability to connect via SSH using the root user. We also